Okay, so we are going to talk about little o and big O notation again, but now the limit is when h go to 0. So you see, now when h go to 0, we have to look for the lowest order term, because when h go to 0, then this term will be bigger than, the h squared and h cubed terms. So in the first example, show that for this expression, then alpha h is big O h, like the smallest degree is the most significant term when h go to 0. So formally speaking, we have to take the limit of absolute value alpha h divided by h, because it's order OH, and you take the limit when h go to 0. And when you divide it by h, you have 3.2 h squared for the first term and 46.4 h for the second term, and the last one is 376.9. And now you take the limit, but now the limit is h go to 0. So when h go to 0, the first term go to 0, the second term go to 0. Only the last one remain a constant. So you got a constant, a finite constant, less than infinity. And so by that definition, then alpha h is just the big O of h, okay? So in the second example, so now you are given alpha h is like this. So show that it is a big O of h squared and a little o of h. So maybe we do the little o first, yeah? So the little o h is like, when h go to 0, then this one, will grow slower than h. So you take alpha h, you divide it by h in absolute value, and you take the limit when h go to 0. So when you divide it by h, then the first term will be 3.2 h squared, and the second will be 46.4 h. And then you take the limit when h go to 0, and you will see that this one go to 0 because h go to 0, this one go to 0 when h go to 0, so the whole limit is go to 0. So therefore, alpha is just little o of h, okay? And now, how about the big O notation? So this expression will be big O h squared, which means that when h go to 0, then the significant terms is just the term of order h squared. And formally speaking, we have to take the limit. We take the limit when h go to 0 of alpha h divided by h squared in absolute value. So we take the first term, we divide it by h squared, then we get 3.2 h. And the second term, we divided by h squared, then we got 46.4. And when you take the limit, when h go to 0, the first term go to 0, but the second term stay at 46.4. And you see, because this is a positive and finite number, so we conclude that alpha h is a big O of h squared. So you see, when the parameters go to 0, yeah, then the big O notation just capture the lowest order, yeah, so the lowest order term. So here, the lowest order term. So it's like the significant term when h go to 0, okay? So that's it.